Hi, welcome to the Introstat lecture series. And in this video, we're going to do an midterm exam number 1 review. And we'll cover some key concepts in this review and work on some type of the problems at the same time here. Okay, so let's go ahead and start. And right, okay. So the first thing, as we mentioned before, we talk about the power type 1, type 2 errors. It's such an important concept, right? So let's go ahead. So the problem number 1 is asked, what is the power? Okay, so power, the way we define the power is when we have a false non-hypothesis and we reject, right? So we say, so when the H0 is false, okay, then we will reject H0, right? So that will be what we say is the powers, right? So let's see which one is correct. So let's say it's the probability is a false alternate non-hypothesis, and we will reject the non-hypothesis. So it's a part B here. Okay, so then the next one's here. So the problem number 2, we talk about the hypothesis that the analyst is trying to prove. So what type of hypothesis we call? The analyst try to prove, right? So it's basically, we said it's researchers, right? So it's the research hypothesis. So what is a research hypothesis? Is also we call the alternative hypothesis, HAs here. Okay. Okay, so now number 3 is here. So we say, which of the following p-value give you the most confidence that the non-hypothesis is false? Okay, so we say the smaller the p-value provide the stronger the evidence, right? So the smaller the p-value provided the stronger evidence. That means we have more confidence that the non-hypothesis is false, right? So the smaller p-value, so which the value is the smallest ones here will be A's, right? It's 0.0023 is smaller than all the other. Okay, now number 4 here. So we say, which of the following are the correct non- and alternative hypotheses for testing the claim that the percentage of the U.S. adults who are current smokers is greater than 19%. So remember we said that the things we want to test is on the what? Is on the alternative hypothesis. So the alternative hypothesis we say is greater than 19% or is 0.19. And then the non-hypothesis we typically put it is equal, right? So it's P is the probability, is the percent, right? So this is not p-value, right? So be careful. This is what? This is the percent. That's the percent we try to test, right? So P is equal to 0.19, that's the non-hypothesis. So the things we want to test is alternative hypothesis. So which one is the correct answers here? It will be what? It will be A's, right? Okay. Now let's see here. Number 5 here. A test to screen for a serious but curable disease is similar to hypothesis testing, with the non-hypothesis here of no disease and alternative hypothesis disease. If the non-hypothesis reject, treatment will be given. Otherwise, it will not. Assume that the treatment does not have a serious side effect. In this scenario, it is better to increase the probability of which error. Okay, so for this type of problem, like we talked before, the strategies here, let's write it down. What do we have? This is no disease. Right now, alternative 1 is the disease. Okay, so see here the keyword, right? We need to screen a very serious, but it's a curable disease. So, so what we are concerned here, we want the power, okay? So we want so we say, okay, so we really want, right? So if the person has disease, right? If the person has disease, then we want to be able to screen that. Then we can screen and give the treatment, right? All right, so we want to be able to screen. So if the person has the disease, so what is this one here? This is H0 is false, right? Remember we said we always write it down and we know exactly what we are looking for. Then we can screen and we say, okay, this person, if this person has a disease, we will say has a disease because this is a very serious disease and we want to be able to cure it. So that means what? We're going to reject the non-hypothesis, right? So H0 is false. If it's have the disease, we want to be able to reject it and then give the treatment. So we want this probability is what? We want this probability is high, right? So we want this one, so we want to try our best to make the whole distance as high as possible. So now after you do that, you say H0 is false, we want to reject H0s, right? So have a false group, the false H0 we reject. What is this thing? So what is this thing we want to hide? This is the power of this test, right? So we want the power is what? The power we want is high. So what is the power? Power is 1 minus beta, right? We want this one to be what? We want this one to be high, right? So if power is high, then what is the beta going to be? The type 2 error. So what is the beta going to be? The beta going to be low. Correct? So the beta to be low, then we know the alpha and the beta, they go opposite. So what happened to here? The alpha going to be what? Alpha going to be high. So what is the alpha? Alpha is a type 1 error. So we want make the type 1 error. We want to, so they say here, what is the better, right? Read the problem very careful. What is better to increase the probability of what? So we want to increase the probability of the type 1 error. All right. So the type 1, so these two, we cancel that out. This is not going to be our choices here. So they said the type 1 error, so we agree we want to increase the type 1 errors. And then they said here, providing the treatment when it is not needed, or is not providing the treatment when it is needed. Okay, so what is the type 1 error? Is when, okay, so now we can rewrite this one, then we will be able to get the answer. So type 1 error when H0 is true. That means this person have no disease, and we reject H0. That means we think this person have a disease, and then we will give the treatment. All right, so that is why. So we provide, so what will be the correct answer? So we say, okay, the type 1 errors here is going to be provided the treatment when it's not needed, right? So when H0 is true, we reject H0. That means we're going to give the treatments here. And so in here, it is okay because it said, okay, so it said assumed here, this is another key things here. They said assume the treatment does not have a serious side effect. Okay, so that means if you give to the people really doesn't have a disease, you give the treatment will not cause the serious side effect. So that's why we said A will be the the correct answers here. So these problems here, we need to be very, very careful, right? The previous 4 problems are pretty straightforward. So this we need to be very careful. See here. Okay, number 6 here. We said a student surveys her neighbors in the residence hall and ask how many siblings each person has, which of the following will not be a valid way to display the result? So we know when you ask the siblings, right? So most likely, you know, you will have the data type is like 0, have no siblings, and 1 siblings, 2 siblings, and maybe 3 siblings. And so most of the number probably jumping around here, right? So I know it's kind of like a discrete, 0, 1, 2, 3. So pie chart is a good chart. Bar chart, right? So bar chart, you can do a bar like this, right? So you say, okay, so this is 0, this is 1, 2, 3. Then here, this is others. So that's more than 3 siblings, right? So then you can do the bar chart like this. Right? So something like that. So pie chart, then you can see here, right? So you can do different pie here, right? So this is maybe is 1, this is 0, this is 2, this is 3, or this is others, right? Okay, so the bar chart and the dot chart is good also. You can do the same way. The dot chart is 0, 1, 2, 3, and here is others, right? Then you can do how many dot here, like that, right? So dot chart is good. So the histogram is not a good way to, you know, to display the result, because in here we probably only have very, very few the classes here, right? So the histogram is good for the continuous type of the data. So here is not a good, probably is not a good one to do that. Okay, so number 7 here. Okay, so let's go ahead and start. So the number 7 is in a criminal jury trial, one option is wrongly convict defendant here. So in the hypothesis testing, this is equivalent to which conclusions here? Okay, so we know that we did this many, many times, the criminal trial. So this is what H0 is what? H0 is innocent, right? And what is HA? HA is guilty. Right, so the H0 is innocent, HA is guilty here. And so in here we say, okay, it's wrongly convict, right? So that means this person is innocent. So it's H0 is true, right? So that's the wrongly convicted. So this person is innocent, but we say it's guilty. So we reject H0. So we are making what? We are making the type 1. Right? So we are making the type 1 error. So what is the answers here? So type 1 error, that means we are rejecting the non-hypothesis, right? So we are rejecting the non-hypothesis. So when H0 is true, we are rejecting the non-hypothesis, right? And because this is error, so we say we are rejecting the non-hypothesis without significant evidence. So that's why we are making the we are making the arrows here. All right. So now the next thing here is which of the following is an example of quantitative discrete data? What is means discrete, right? So the discrete, that means you can count. All right, so you can count like 1, 2, 3, 4, like this. There's nothing in between. Okay, so the quantitative data, we can have 2 kinds of the quantitative data. We can have a discrete and we can have a continuous. So the discrete is the type of the data you can count like 1, 2, 3. You have siblings, right? So 1, 2, 3, 4. You don't have 1.5, right? So there's nothing in between. The continuous is the type of the variable, is you always be able to continue to divide into the smaller units. What I mean, for example, time is a continuous. So if you say, how long take you to finish this exam, you say 50 minutes, you say 45 minutes, right? Is it exactly 45 minutes? Probably not. So maybe you say it's 45 minutes and 10 seconds. Is really 10 seconds? No, probably it's 45 minutes and 10 seconds. Maybe it's like 10, like 10.2 seconds here, right? So it's 10.2 seconds. If you can continue, because we cannot exactly, maybe we just don't have a measurement units anymore. The second is our smallest unit. You can say the tenths of the seconds, hundreds of the seconds, right? So you can continue divided. So that like this type of the variable, we call it a continuous. So for example, you say how, how heavy you are. You say, okay, I'm 130 pounds. Are you exactly 130 pounds? Or maybe not. Maybe you are 130 pounds and maybe 3 ounces, right? So are you exactly 3 ounces? No. Maybe you are the tens of ounces or hundreds of ounces, right? You can continue. You just, your measurements instrument is not precise to that degree, but you can continuously getting smaller and smaller unit. So I don't know, I'm exactly the 130 pounds and 3 ounces, or maybe I'm 130 pounds and 3.00004 ounces, right? So those type of data is called continuous here. So now for these ones here, they ask us for the discrete data. So the discrete data, we said number one here, the circumference of the American women's wrist. Well, so if you are, depending on what type of the measurements you use, if you use the centimeter, then you can continue to divide the centimeter to the millimeter or the even smaller units, right? So this is a continuous, right? So this is a continuous. So the second part here, the amount of the time spent playing computer game, this is a continuous. We just talk about the times here, right? You can continue to divide into the smaller unit. Total number of the phone calls made in a week. So the number of the phone call, you can exactly count 1, 2, 3, 4, 5, 6, right? So this is a discrete. And now let's take a look at here, the length of the elephant's tusk, right? So the length depends on how do you measure it, right? You said, like maybe 54 inches. You say exactly 54? Maybe not, right? So maybe it's 54.0012. Or maybe it's 54.000012. You can continuously divide into the smaller one. So this one is a continuous also. So the answer is C here. Okay, so be very careful about the differences between the continuous and the, the continuous and the discrete, right? Okay, so this one, number 9 here is just to see the piping concept in the R. If you did the R project by yourself, so you know the piping, that means you transfer the information to the next steps, right? So piping is here, right? Okay, all right, that's good. So next one's here, we say a medical research. All right, a medical research measures the increase in the heart rate of a patient who are taking a stress test. What kind of the variable is the research study? So the heart rate, so you have a 65 heart rate or 72. So those are what we call, those are the quantitative variable. Right? So we know this is a quantitative variable. The reason why we say this is a quantitative variable, because a quantitative variable allows you to do the computation. Right? So the computation makes sense. You want to find the average, you want to find the biggest one, smallest one. So you want to find the range. It's meaningful. And all the categorical data, the computations does not make sense, right? So the identifier variable is the categorical. Ordinal is like you rank, right? Like you rank is satisfied, not satisfied, right? So the categorical data, nominal is like For example, which brand, the car you have, which manufacturer, you Ford, Toyota, or GMs, right? So this is not, so this is the quantitative type of the data. All right. So the number 11, we said type 2 error. Oh, I think that we did this ones here. So the type 2 error is when the, okay, so let's try to review what is type 2, right? Type 2 error, we said a type 2 error, let's see here. Type 2 is when H0 is false and you fail to reject. Okay, so let's see which one is left here. The non-hypothesis is not a reject when the non-hypothesis is truth. No, it's not this one, right? We said non-hypothesis is false. The non-hypothesis is rejected when the non-hypothesis is true. No, the non-hypothesis is not rejected when the alternative hypothesis is true. Okay, and so let's see here. This one is okay. So the non-hypothesis is not rejected, it's failed to reject. This is okay. Then when the alternative hypothesis is true, so the other word for the alternative hypothesis true is what? It's H0 is false. Correct? So wow, so let's match my type 2. So it's this one here. So it's a non-hypothesis, it's a fail to reject when the alternative hypothesis is true. All right, so the then part D is a non-hypothesis rejected. So that's not true. We say non-hypothesis failed to reject it. All right, so it's a C here. Okay, so number 12 here, the SPCA collect data about the dog house, which is a categorical. All right, so the categorical is not numerical, right? So categorical, that means it's not numerical. Okay, so which one is, oh, the breed, right? So I have a Cocker Spaniel, I have a German Shepherd, right? So the, like age is numerical, weight is numerical, that cost is numerical, time taken to be adopted. All these four are numericals, okay? All right. And so number 13 is here, they say a study began in 2011, examined the use of the stem cell to treat two-formed anosmia, and each of the 36 patients enter one of the two separate trials, and in which embryonic stem cells were to be used to treat the condition. So identify the who's here. Okay, so what is the who? Who in here is the what? Is the 36 patients with what? Anomia, right? So the way you identify who, like I mentioned before in the class, is typical like you read like the data paper like here, right? So they take these 36 patients, right? So this is the patients, right? So number 1, number 2, number 36, right? Then they ask them some questions here. Those are your what? Those are the what, right? So those are the questions they ask, right? So the first columns here for the data typical is what? Is our who's here. Okay, and then the number 14 is here. We said a good data set. We have 5 W's here due to different reason. Sometimes some W's were missing. So which 2 you should always have in the data set? What is that? Who and the what? Correct? All right. So number 15, this is another one is interesting. Sometimes you get stuck in the R. We call it is the plus hell. That means when you hit enter, 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 then the R will always still give you a plus. Don't, you know, like the, you can never get out this plus hell. So, you know, from the R video, we said, how do we get out? How we hit escape keys, right? So let's escape the plus helps here. Okay, number 16 is here. So suppose that the manufacturing is testing one of its machine to make sure the machine is producing more than 85% of the good parts. So this is the hypothesis. The test result with a p-value is 0.002. In reality, the machine is only producing 83% of the good part. So what probably happened as a result of testings here, right? So like we talk about for this type of problem, let's always write it out, then will be better. So we want to test this is greater than 0.85. So we said the machines really produce is 83%. That means it's less than 85, so it's in the H0s, right? So this statement is 83%. That means what? When H0 is true, right? Okay, so this is that when H0 is true, when they say is that the machine really produce 83%, that means it's not greater than 85, so it has to be in the H0. So when H0 is true, then they tell you the p-value is 0.002. So what's that mean? The 0.002 will give you what condition here? Is smaller. We reject what? We reject H0s, right? So we come to this conclusion based on this information, 0.002. So when H0 is true, we reject H0. Let's see which problem we make. We are making the type 1 errors, right? So this is a type 1. Okay, so now let's see here. So first one here is that we correctly fail to reject. Well, we did not fail to reject, so it's not this one. So it said we correctly reject. No, H0 is true, but we rejected, so we did not correctly reject. So then number C is here, say we reject H0, make a type 1 error. Oh, here, correct. Right? So then the part of this here, let's see where's the problem is that we fail to reject, right? We did not fail to, we reject, right? And then the part E say we reject, that's okay here, but then they say to make the part 2, type 2 error. No, we made a part 1 error. All right. Okay, next problem is here. So which of the following areas belong to statistical inferences here? Okay, so what do we talk about? We have 2 branches of the statistics, is inference and data analysis, right? So inference is what does inference mean? That means you will be able to use the statistic information to estimate or to forecast or to test the hypothesis here, right? You don't really doing the graph anymore, right? So now let's see here. So let's see which one. So the first thing they say, construct a different graph. No, that is belong to the data analysis part, right? So it's the graphing part. Conduct a regression. Oh yeah, the regression line. That means we want to know the relation between the two so we can estimate. Calculate some summary statistic. That's not belong to the inference. Create an estimation model based on the data and estimate the population. Oh yes, this is the one because we said inference cover the estimate, forecast, and test hypothesis, right? So to develop the survey and collect the data, let's belong to data analysis. So will be 2 and what? 2 and 4. So it's D. Good. All right, let's take a look at number 18. So the number 18 says a random sample of 1,000 college students was asked whether they ever used the drug at, I think it's hypotheses. 16%, all right, 16% of the 1,000 students they surveyed said they had. Which of the statement is this is 16%? Right, you surveyed 1,000 students, right? So this is what? This is your sample, right? So 16% is based on the sample. So if it's based on the sample, then is what? Is a statistics, right? So we call it is the, if the data is based on the sample, it's a statistic. If the data based on the population, is what? Is a parameter. So what is here? So this is a test statistics here. Okay, so let's test the statistics here. Okay. Oh, I'm sorry, it's not a test statistic, it's it's the test is a statistic, so it's a sample, all right? So it's not a, this is the sample proportions here. You base on the sample, so this statistic is the sample proportion. Okay, so it's based on the sample, right? So the test statistics here, that's a different thing here. So here, this is a test statistic. So that means we defined like it's z-test or t-test, but this is a pure just a statistics here. So it's a sample proportion. Okay, so now let's next one's here. So next one's here say a result is called statistical significance. What's that mean? That means null hypothesis true? We don't know. Is alternative hypothesis false? We don't know. Is it a two-sided test? I'm not sure. No, doesn't mean the one side can be statistically significant. The p-value is less than or equal to the significance level. Yes, right. So we say when the p-value is small, then I have a significance evidence. Then the p-value is larger than the significance level. That's not true here. Okay, now let's take a look here. Number 20. All right, so we will test the hypothesis P is equal to the H0 versus the P equal to the less than. So this one, this is H0, this is HA. And we don't know, but actually P is 60%, right? So the P is 60%. That means the HA is true, right? So this is HA is true. Or if you say that, you can say H0 is false. And so they said which sample size and the significance level will have our test has the greatest power. All right. So remember we talked about in the class, we said the only one factor it will decrease both type 1 and type 2 error and increase the power. What is that? It's the sample size, right? So we said the larger the sample, is more powerful. All right, so we have a sample size 200 and 500. So I can cross out the 200 one, right? So I can cross out the 200. Now I have both 500 because I know the larger the sample is more powerful. Okay, so the greatest power. Okay, now let's take a look again. So power is 1 minus b, right? So power is getting bigger. Then what is the betas here? Beta is what? Beta is getting smaller, right? Beta getting smaller. Then what is the alpha here? Remember this very important table we talk about, the alpha going to get bigger, right? So compared to here, so with both is 500. So which one will get the greatest power? This one. All right, so it's alpha equal 0.05. Okay, number 21 is here. Consider the following experiment. You flip the coin 4 times and record the number of the flips that result in heads. The possible outcome from 0 to 4 heads. Now imagine you repeat this experiment 100 times and record the result for each time. Which of the following displays most likely to represent the number of the time for each possible outcome? So we know, right? So we know we have a half and half chance, right? So we need a half and half chance to get a tail and to get a head, right? So if you for the cone 4 times, right? So if it's half and half, so most likely you will get 2 So what is this, right? Number of times you record, so which of the following, right? So now if you record, for 4 times, you probably will get a 2, let me see the record number of the resulting head, right? So the average, you will get what? 2 heads out of the 4 times, right? So most likely to happen, right? So because, each one have a half and half chance, so 4 times, most likely you will get a what? 2 head. Of course, sometimes you will get 1 head and 3 tail. So the most likely the graph will be what? Will be C's here, right? Will center around the 2 heads. And then when the number of the head increase or decrease, think about that. What is the chance you will get when you flip a coin like 4 times, you will get 4 heads. It's a lot smaller, you will get a head and tail mix, right? Just like in here, what is the chance you will get 0 head? Also, it's very small, all right? So the most likely they will concentrate on the middle here. Okay, now number 22 is here. So number 22 will tell you a hypothesis test is done, which alternative hypothesis is that more than 10% of the population is left-handed. The p-value of the test is 0.25, which statement is true. Okay, so do the same way. Before you look at the answer, let's write it. So what is the hypothesis here? So alternative hypothesis more than 10%, so it's p greater than 0.1. So p is equal to 0.1. So then they tell you the p-value is 0.25. P-value is 0.25. Okay, so with the p-value is 0.25. So what do we do here? So because p-value is pretty big, so what do we say here? We fail to what? Reject H0, right? So that means we are stated in here, right? So let's see what is the statement is here. Okay, let's see here. We can conclude that more than 10% of the population is left-handed. No, we say we're going to state it here. We fail to reject. So this is not true. We can conclude that more than 25% of population is left-handed. Oh no, because the p-value is not the 25% of the population. No. So part C said we can conclude exactly of the 25% of the population is left-handed. No, p-value is not this p-values here, right? So this p, this is the parameter. This is the percent, right? Percent of the people will be the left-handed. So then the last one here is that we cannot conclude more than 10% of the population is left-handed. That's correct because we state here, right? Non-hypothesis. So we cannot conclude more than 10%. We cannot support HA is here. Okay, then next one's here. Number 23, so it says, which of the following values is not a typical used for alpha? We said we want an alpha like small, right? So the 0.25. So all these 3 are the most commonly used. We talked that during the class. Okay, number 24. So we say the dot plot, all right? Which statement is not correct? Okay, let's see here. Part A, they say plot indicate there are some outlier of both ends. Well, it's kind of right. This one is kind of like outlier. This one is kind of outlier. So this one is okay. So it's correct. Okay. So now let's see here. The part B, they say more plot indicate female runner. This is a female runner. Plot fit a unimodal distribution. Well, the unimodal is in here. It seems I have like several peaks, right? So I have like several peaks. So it doesn't look like a unimodal. So this probably is not true. Let's take a look at the other one. to see we have any other one will be not true. Let's say most of the runner probably bigger than 90% will be between 20 and 60 years old. So you look at your data here, this is, let me get a different color, is, here, green one. So this is 20 and this is 60 years old. So like most of the runner in this range, let's say probably is greater than 90%. That is kind of true because the majority of the data is here. I have a few here, I have a few here. So greater than 90%, that is a correct statement here. And then the next things here, they said, the distribution skew to the right slightly, but not much. It's kind of true. So it's kind of like you have like a little bit of tails here, right? So you have a little tails here, right? So of course you don't here, this ones could be like right? So then you have a little tail, but not too much. So this is a true statement. So the only thing is not right is what is a part B here. Doesn't look like a unit model. It's have like a few peaks there. All right, let's take a look at the last three problems here. Number 3, we said developing a new drug can be very expensive process, resulting in very high cost in patient. A pharmaceutical company has developed a new drug to reduce cholesterol, and it will conduct a clinical trial to compare the effectiveness to the most widely used current treatment. The result will be analyzed using a hypothesis test. If the test yield a low p-value and reject the research and the research reject the non-hypothesis that the new drug is not effective, but is actually is not better. What are the consequence of such error? Okay, like we mentioned before, when we do this type of the problem, let's always write it out. So don't let it to confuse us. So the H0, this is not effective. Okay, so HA is here, this is effective. All right, so let's write it. All right, so the result, and so if a result lower a p-value, okay, so let's say the lower p-value. So what does that mean? The lower the p-value, that means I'm going to reject alternative non-hypothesis, right? And the research then reject non-hypothesis that new drug is not effective. But actually, look at this sentence, they say actually is not better. So what is this sentence give you? Actually is not better. So it's actually is not effective. So that means H0 is what? H0 is true. Right? So that means that when H0 is true, I'm rejecting H0. So now let's translate to what here. All right, so we said H0 is true. That means it's not effective. But we say it's effective. Right, because we reject, we say it's effective, and the defective, this new drug is very expensive. Right? Okay, so now let's see what that means, right? So we said that people will miss the opportunity to use a more effective treatment. No, right? So this is not right because this treatment is not effective. Okay, so let's say the company may lose some of the reputation for reliable quality and honest advertising. And no, we don't know about that, right? So then the part C says people will pay more money for a drug, right? Because this drug is pretty expensive, but it's, you know, if it's effective, it's okay. But if they pay more money for a drug, it's no better than the widely, because it's you pay more money, but this is not effective. That is the type of the error we're making here. Let's take a look at part D, what's wrong with here. the company will lose potential revenue from selling the drug here, right? And so no, because because it's a high cost to the patient, so the company probably charge a very high amount of money for the patient. So we don't know we will we'll lost the potential revenue. We're not going to, because we say it's effective, right? So the correct answer should be C here. Okay, so now, all right, so here we say number 26, we say here, a research center conduct extensive survey consist of the interview and the medical examination with representative sample here, okay, about 5,000 people a year. The interview include demographics, socioeconomic, dietary, and other health-related questions. Then the examination consists of the medical, dental, physiological measurements, as well as laboratory test treatment, So describe the sample and the populations here. We already see these keywords, right? So in this, okay, so let's see the answers here. Be very careful, right? So in this case, the sample or the population are both 5,000 people. No, we don't know what is the population, so this cannot be true. The population is, okay, so this is the 5,000 people each year partake the survey. The sample is the number of individuals that in a certain demographic. No, that's not true. The population is all people. The sample is 5,000 people each year. Yeah, this is the one, because they say it's the 5,000, they did not specifically so specify the population, so we assume the population is all the peoples here. So then the part this here, and they said the population is all the employees. No, this research center, we do not say it's all the employees. It's not, right? Okay, so number 27, see here. So instead your survey over 2,000 US teenagers by Harris Interactive, 47% say their social life would end or worsen without their cell phone. So now one survey question asked teens how important it is for their phone to have certain features. The following figure displayed the data of the percent who indicate the particular features is vital. Explain which graph principle misleading, okay? So let's say, should I use the bar instead of cell phone figure? All right, so let's find area principle. So when we use the picture, we're very careful. So like this one's here, we are violated the area principle. So what I mean the area principle, in here that we know like a certain phone, that's what is this make and receive call, we say is so important, it's 46%, and this is 39%, and this is 19%. In fact, the area, so if the 46%, then this cell phone screen should be like a 39 compared to the 46. So you can see like 39 compared to the 46, how big the percent. And then this one should be like the compared to the 46 also, to see like what is the percentage like. So when you use the picture, typical, we violate the area principles here. All right, so that's it. Okay, so this is the, this is very, very, of course, like for this problem, let's say they're missing the graph title, but we are want to find is the most, the most important principles we violate here, right? So it's the area principle. Okay, that's it. That is like the, we covered the majority of the, similar type of the problems will be covered, in the exam number 1, and good luck when you take the exams. All right. Okay, bye. And have a good day. All right, bye-bye.